So now we will go to the another process. Okay, let's look at that. Another part of our assignment in strategic tool is to understand the ER diagram. Okay, we will spend now, we have covered the data flow diagram. Now we are going to cover the second part of the strategic tool, that where is very important is the ER diagram. So let's understand what is an ER diagram. An ER diagram is a data model is based on perceptions of the real world. That is consists of an object, which is called an entity, and those two entities, there must be a relationship between them, and the relationship be among these entities. It's developed in order for us to understand the reality of the system in terms of object and relationship. It will facilitate for the implementations and the creations of a database. So it's developed to facilitate the database design by allowing us to understand the object, and then we understand the attributes in these objects. We understand basically the primary key and the foreign key. So if you see in our theoretical modules where we cover the subject, we discuss in detail about the ER diagram. An ER diagram is basically a rectangle and has an attributes and also has a relationship. So think about if I want to do an ER diagram for a student and a course, or I want to do an ER diagram for an employee and a department. So here, for example, in the real world, I have here is an example. Here is an employee, and then employee is represented by employee name and also employee number. Employee works in a department, and employee basically has belong to a nationality, and an employee works on a projects. And in this case, he works on a multiple projects, 1 project, 2 project, 3. So let's understand if we have, this is a screen that we want to model it. To model it is mean we need to do what? In the data flow diagram, it shows us the processes and the external entity and the files. Shows how the data are flow, data are stored. In an ER diagram, it shows us what is the entities, the object, and the relationship between them. Because in a database is a collection of tables, and a table is called an entities. And these entities, think of them, they are separate objects. There must be a relationship between them. So let's look at this one. An employee means there is an employee entity, and a department means there is a department entity. In this case, we call this an employee entity. And in a database, we call that employee table. And then we have a department, mean there is a department entity. Now, there is a relationship between them, and this is, we say, employee, many employee belong to many department, or many employee belong to one department. Many employee belong to one department. In this case, we say working or belong to a department. So now, we will need to discuss what is ER diagram. All right, The second part of your strategic tool is to cover entity relationship diagram. An entity relationship diagram differs than the data flow diagram. A data flow diagram is composed of external entity and processes and how the data are stored, okay, in which files, and the flow of data. So it shows me a presentations of the processes and the files, which files belong to that process, and the data flow and the external entity. Where in the entity relationship diagram, it consists on entity and relationship. An entity relationship diagram model is based on the perceptions of the real world. That consists of a set of objects. This object called student, employee, course, department, nationality, car, building, and relationship between them. Example, a person and a car. A person is an entity and a car is an entity. We need to understand the relationship between them. This car, this person on this car. It was developed to facilitate the design, because from an ER diagram, we go to the second level, which is what? Which is a database design. The design of what? Of the database for an enterprise. It's a logical representation for database management system. An ER diagram consists of an entity. Example, we have here in this case an employee number. We have employee name, we have a department name, we have a nationality, and we have a project this person is working on. An employee is an entity, okay, which is a file, which is a table. In these things, it consists of the name of the employee, first name, middle name, consists of the gender, consists of the address of the employee, consists of the hire date, consists of the nationality. Here is the department entity, mean the department name and department number. So if you look at it, the entities is the rectangle. It's represent of what? Rectangle. Example, student. It's the entity student, okay, student. It has attributes. We call these are LEPs. We call them attributes. They basically, an attributes, they are field, and an attributes has an identifiers. Example, multi-value, primary key, single value, which is we're going to cover. And between an entity and an entity, there is a relationship, which is in a diamond. It's a graphical representation, because as you see, this is the graphical representation. You could see it visually in order to understand the overall structure of the database. So here is a student, is an entity. We have an entity student. We have an attribute called student ID. We have an attribute called student name, and other attributes could be gender. Now, for an entity, it has to have a primary key. Mean, it have to be indexed, because it's a table. It must be fast retrieved. So we cannot have a duplications. So we must have one of the attributes to be a primary key. In this case, that attributes is a unique. A unique number is your student ID. There is no student duplication in the student ID. Mean each one of us, when he is in a college, he have a unique number. That unique number called student ID. that unique number is called a primary key. Usually a primary key is, in this case, a student ID. It's represented by underline. So whenever you see an entity has an attribute, with that attribute is underlined, mean this is the primary key. In our example, an employee, the attributes could be an employee ID, an employee name, an employee gender. In this case, employee underscore ID, underline, okay? In this case, it is the primary key. Now, we need to understand the concept of, because it's in your assignment, the strategic tool, the concept between a strong entity and a weak entity. A strong entity is an entity exists independent of another entity. Wow. Example. I have, in my example here, okay, a student is a strong entity. Why? Because a student can exist independent of whether he takes a course or not. In this example, a strong entity exists independent entity from the others. Example, I could have a supplier as an entity, and I could have a part. In this case, a supplier in my database, I could have a supplier, mean I have an entity supplier that could exist in my database, but he maybe will not deliver any part for me. In this case, we call that a strong entity. I can have a part, and this part exists, and it could not belong to a supplier. Also, in this case, a supplier can be, and parts can become independent entity. So the relationship is between entity supplier and a part is supplier supplies a part. In this case, I can have an employee and this employee and nationality. I can have a nationality exists as a value without any employee I have in my company has that particular nationality. So in this case, this is a strong entity and this is a strong entity. Example, I can have an employee, okay, who is basically, he is exists independent, and nationality exists independent without any nationality. Now, we have another one is called weak entity. A weak entity is an entity that depends on another entity. Example, a weak entity is a relationship in which we basically say it's a representation is a double line rectangular. In this case, an employee and dependent. I mean that dependent, a child cannot be, okay, exists if there is no parents. In other words, employee has dependent. This is a strong entity. This is a weak entity because I could have every employee that exists, but some employee don't have an independent. But if I have a dependent, they must belong to what we call belong to an employee. So in this case, dependent depend on an employee. We call this dependency. In other words, this is a weak entity. So let's look at that. A professor related dependence. A professor is an entity. Some professors, they have children. Some professors, they don't have children. A professors have an attribute ID, which is a primary key, a name, a city, a salary. These are attributes belong to a professor. Where the weak entity is the dependent. Why? Because we could have some professors, they don't have children. Therefore, entity dependent is a weak entity. Here is an example of a strong entity. Okay, customer is a strong entity. Student is a strong entity. Nationality is a strong entity. Okay, parts is a strong entity, and supplier. In other words, these entities, they are existing independent. I could have a customer exist in my database and has not placed an order. I could have a student exist and he has not taken any course. I could have a nationality in my system of a customer, but I never had any transaction for that particular nationality. I could have a supplier exist, but he does not supply me any parts. Now we have, here is a weak entity. Employee is a strong entity, and this is a weak entity presented by double line, rectangle, okay, and it is dependent. So an example of a weak entity is an employee has what we call dependence. So dependence in this case is a weak entity. Now we need to understand simple entity. A simple entity is basically student ID, gender, and student ID is, again, I have a student, okay, student. Simple entity is a student ID. I also, because it's an ID, it's a primary key. A student gender. Another one, nationality. Mean it is a simple entity. Now, I have a composite. What is a composite? A composite is a name. In this case, I have what we call, okay, employee. Okay, again, simple entity is employee underscore ID and employee name. Employee underscore name. Employee name is a composite, meaning that it can be broken down into another attributes. In this case, first name, middle name, last name. So, in this case, I have an employee, employee name, employee first name, employee middle name, employee last name. Same things, I could have a student, and again, student ID is a simple entity, and it is since a primary key underscore. I could have a student name or a student address, and these are composite attributes, mean they consist of multiple attributes. In this case, first name, middle name, last name. Where address, it could be zip code, building, road, and so on. So we call that composite. Again, a composite is address. That's composite. It's breaking down into what? Into different attributes. So when you look at your address, it consists of building, road, block, flat, city, zip code. So an address is a composite. It's breaking down into symbol, okay, other attributes, components of street, address, city, and state. Now, single value, okay, is date of birth. Example, I have a student, okay, example, student, date of birth. That's a single value. Me, I'm storing only one single value. Gender, employee gender, usually every employee have one gender, male or female. So I am storing one single value. So we call it single value attributes. So if I will come here and say, okay, gender, employee gender, it's a single value. Date of birth is a single value. If a person have, okay, belong to one department, that's a single value. So, multi-value mean that the field has more than one value. Example, a customer, okay, can have multiple values. So example, a customer can have more than one contact address, more than one mobile. A customer can have more than, example, more than address, has multiple address. A customer can have, for example, a student can have more than one qualification. So example, an employee, and this employee, okay, the field has multiple value, mean an employee can have what? Multiple skill or more qualification. In this case, we represented it by an olive, okay, double, and we call it qualification. So an employee can have more than one value qualification. He have a BSc, master's, high school, okay, so can have more qualification. Or if it's a student can have more than one qualification. Or if it's a contact, a person can have more than one email, more than one mobile. That's a multiple value. An employee can also have more than one skill, so that is a multiple value. Derived mean that we have example, we have wine, we have here the date of bottling, and then we have the age. In an example, we have an employee, this is an employee, and we have the hire date, mean the date we hire him, and we can calculate another field. We say how long, okay, serve the company. So mean a field, from this, the date, example, your date of birth, okay, a person, date of birth, we know your age. So we call it that derivative field. Example, student is how many points, okay, and then we calculate the GPA. So in this case, take an example. A derivative field, we have here your date of birth, student as an entity, date of birth, okay? We know your age. We have a student, how many credit taken, and grades and marks, we calculate the GPA. Employee number, when is he hired? Year is hired, we know how many years he worked. Car is the manufacture date, and we know how old is the car. So let's do this together, okay? Let's say we have here, okay, a field, and in this field we call it student, okay? And then we have a student date of birth, okay? And we can have here another calculated field, okay? Another calculated derivative field is the age of the student. Now we can have another example, okay? We could say a car, in this case, we say a car, here is a car, okay? And a car is the manufactured year, okay? And here is the age of the car. Now you could have another example. You say, okay, I have a product, think about it like a milk, and this is the manufacture date, and then here I have to know, okay, how old is this item. In this case, if this product is manufactured January 2018, and today is, let's say, January 2020, so I know how old is this product. Another one, I can have it differently. I could say, okay, I could have, example, in this case, I could have a drug as a drug. This is the manufacturing, okay, date, and this is period, okay, of validity, let's say 24 months. Here where I have is expired, not expired. So we call that derivative field. Mean is a field. This is based on this value. We derive a value from there. So now we'll go to this one, second one. Okay, we go to this one. No, we go this one. Okay, we go back to this. All right. Okay, now let's look at another example of a derivative field. Another example of a derivative field is that, look at this. This is an entity employee. And in this entity employee, this is an entity. How many attributes I have? I have one attribute, is simple attribute, but it's a primary key because it has an underscore, employee ID. I have employee name. This is a composite attribute because I can break it down into first name, middle name, last name. I have the address, and that is a composite attribute because I can break it down into another street, block, zip code, and city. I have here is the employee date, okay, and here I hire date, and here I can do a derivative field which is called employee number of years is being employed. So this value is he's employed 2000, and now we are in 2020, so that is a derivative value of 20 years. I have here is a symbols of what we call multi-value, and multi-value is a skill, mean this employee has multiple skill. Writing skill, leadership skill, communication skill, has negotiation skill. So one employee has multiple skill. In this case, we call it multiple value. So let's look at this example. This is a very good example. Look at it. The type of attribute. I have a primary key. I have composite attributes, first name and address, employee name and address. I have a derivative, mean multiple value. I could put a gender, which is a single value. I have a derivative field, which is coming from employee hire date, which is a single value. Now, we need to understand the relationship. This is in your strategic tool documents, assignment, where you have here is an attribute, an entity, and here is an entity. Now, you need to define the name of attributes, and here. So here is, you say a student, okay, in this example, okay, a student. And in this example, courses, student enroll in courses. And in this case, a student is an ID. This is a composite name for name of a student, which is first name, middle name, last name. Here is student earned, student enrolled in a course. The course ID and course name. So now this is a relationship. This is an entity, and this is an entity, and this is a relationship. Now again, we go to your what we call the strategic tool. You have to understand different relationship. Honorary relationship mean a relationship between the instant of a single value. Example, an employee could be what? He could be an employee, and he could be a manager. So within the entity, we have an employee, and we have an employee, a manager. So in other words, we call it honorary. Another one is binary, is student and enroll in a course. Mean that binary relationship instant of two entity, where here is within the single entity. In other words, in this one, okay, this one, and this one, let's get it all here. In this one, it's the same entity. Example, an employee, okay, he could also be what? Could be a manager, okay? So in other words, he has an employee ID, and when it comes to manager ID, it's also as in this attribute. So we call this honorary, what we call an honorary relationship. Now, we need to go to the second one, okay? We need to go to the second one, okay? The second one is, we need to understand the binary. The binary mean we have the relationship between what? Two entity. This is one entity, student, and this is another entity, student, and this is the relationship between them. Now we need to understand the concept of cardinality. Well, cardinality could be 1 to 1. One person has exactly one tax file, or one business has one VAT number. One to many, a student, okay, sleep in one dorm. Many students belong to one dorm or sleep in one dorms. Many to many is basically many students take many courses. So the relationship we have of cardinality is 1 to 1. Example, one person has one car. So in this case, 1 to 1. One person, an employee has one nationality. Where it's one to many mean one dorm has many students, or many students sleep in one dorm, or many employees belong to one nationality. Many to many employee has many projects. Many employee and many projects. In this case, many to many. In this many to many in a relational database, when we implement the relational database, we need to introduce what's called a bridge table. That means in databases, we have one to many, but when it's many to many, we introduce another entity called a bridging entity. So here, let's look at that. Maximum cardinality is a maximum number of instances that given an entity to be associated with a single of the entity. Could be 0 or could be more. Now look at that. One supplier can do what? Can supply many parts. One supplier can supply many parts. But also we could have one supplier can supply 0 part. So in this case, we can have one customer can have an order. In this case, one customer can have many orders, or we have one customer can have 0 order. So that is minimum, and that is minimum, and that is maximum. So we call that minimum, maximum cardinality. Now let's go to the next. Okay, so we go to the next. This is the next. Let's look at this one. This is again a course. And a course can have what? Can have what we call one to many. Can have what? Many prerequisite. A course can have what? Many prerequisite. Okay. Now in this case, a course can have many prerequisite, or an employee can have a manager, one manager. So here we call it honorary relationship, 1 to 1, or honorary relationship, 1 to many. In other words, 1 to 1, a person is married to one woman. Okay, it's called what? 1 to 1. Okay, in other words, I have an entity, a person ID, first name, address, and married to. And the person that he's married, it's also can have a record for him into my table as a social security number or as an ID number. Here is, I have an owner, okay, and an owner has one car, 1 to 1. Here I have 1 to many, okay, we have 1 to many, we say dormitory, okay, one dormitory, okay, has many student. Okay, many to many, one student, many, we can have many student take many courses. In this case, many to many. Many student, okay, takes many courses. In this case, we need to have a bridging table. Now let's look at this example. Again, this is an example. We have customer entity, and a customer has an attribute, customer ID, has what we call a composite of field of phone. Here is the phone type, and here is the mobile, and has also a name, could be composite. Here is the cardinality, one customer place many order, or one customer can have 0 order. Now here is that a customer, okay, 0 order can have, one product can have 0 order, I mean nobody is ordering it, or one order, okay, can have many products. And in this case, I could have one product has nobody order for it, okay? And in this case, I have one entity is called customer. Customer placed an order. In this case, one customer placed many order. One order has many products or one products. Now let's look at this one. Here is an employee and dependent. One employee has what? 0, no dependent, or one employee has what? Many independent. Now we have what we call association, and in the association, if you look at it, here I have a student, here I have enrollment table entity, and here I have a class. So if you look at it, this is a student entity, and this is enrollment entity, and this is a class. So I could do this. This is a student, and enroll, many enroll, okay, here and here I could do another entity. So in other words, I can have, this is number one, number 2, number 3. Okay, so let's erase all this and let's do this by pen. So I have here is 1 is a student entity, 2 is an enrollment, 3 is a courses. What does this tell me? Tell me that a student, okay, enroll in many courses. So many students enroll in many courses. So this is many to many, but in relational database, enroll. In relational database, I cannot really have many to many. So what I need a bridging. This is a student, which is number 1. This is number 2, okay, and this is number 3. That's 3 entity. Now here is a student enroll in a course. Many students enroll in one course, or one student enroll in many courses. Now the second thing here is I could come and I say many courses here belong to, many enrolled courses belong to a course. So now look at that. We call this the primary key, and which is, here is a primary key for this. So and this one, this is a foreign key. So this is a PK, primary key. This is a primary key. Okay. And this is, because if you look at this 100144 happen to be also duplicated, 10014. This one and this one are the same number. So what I need to understand one thing now, that this is one primary key. This is the primary key. So let's do that. This is the primary key. That's the reason underline. But for this entity, these are both a primary key. We call them joint key. So why we call them joint key? Because if you look at this 100144, which is what? It's a duplicate here. So a primary key should be what? A duplicated. Here, in order to be unique, so I need to introduce another what? Another attributes. In this case, 10014 with plus 32145 is called what? Called a joint key. So that's the primary key for this table. Where now I am going to have a course. This is the class. Okay, so this is the class. Okay, class code. And this is what we call the description belong to it. So we call this, okay, we call this a child. Okay, we call this the child. We call it master table. So again, associated composite is also known as a bridging. This is the bridging. Okay, why? Because I have one entity student and enroll. Okay, student enroll in where? Enroll in a course, and these are the courses. So here is number 1. This is number 2. This is number 3 entity. Number 1 is the student entity. Number 2 is the enrollment entity. Number 3 is the courses. So, a student, one student, we enroll in what? Enroll in many courses. Many courses, enroll courses, okay, belong to what? One course, which is this, the master table. So what we done, we convert many to many into one to many. In this case, one to many, and in this case is this many to one. So in this case, what we have done, we introduce a bridging course, a bridging table. Now, we need to go to this one, and this one is another example. We have a doctors, okay, one doctor prescribe many, do many prescription. Many prescription belong to one patient. One prescription, many prescription belong to one drug. But also we could have Look at that. So one patient, this is a patient, one patient, could have no prescription. Okay, let me clean it up, all this here. We're going to erase that. I could have an instant is that one patient has what? 0, no prescriptions. But also I can have one patient has what? Many prescription. I could also come here, the relationship between the prescription is issued by doctor. Prescriptions belong to patient. A prescription is issued by doctors. A prescription is what? It's belong to a drug, has a prescription drug. So one patient has many prescription. One doctors, look at that, one doctors that maybe will not prescribe any prescription. So this is call it 1 to 0. And then here I have one physician can prescribe many what? Prescription. Now, so I have now many prescription belong to one drug. Example, paracetamol. Example, Panadol. But I could have one drug has never been prescribed by whom? By physicians. So this is a good example to understand the entity relationship. So what does this tell me? This tell me, if we're putting it all together, is as follows. I have a prescription. This is a patient, 101. It has a patient name, first name, middle name, last name. And a prescription, this is the patient, information, gender, okay. Now, the nationality, all right. Now, here is, I have a prescription, okay, which is the doctor's, prescribed doctor. And then, maybe doctor's number, prescribed doctor number, here name, here is specialty. Now here is, I have the prescriptions, many drugs. So this is when you go to the doctors, what do? You see a physician, he writes for you a prescription drug, which is for you as one patient. And this is the patient doctor's information. And here is the drug, okay, code, name, and here is quantity and dosage. So here could be Panadol, could be paracetamol, okay. These are 101, 102. So if you look at it now, look at that. This is an entity, this is an entity called patient entity. Patient entity. This is doctor's entity. This is a whole thing here this is a prescription. This is a prescription entity. Prescription. And now we need to know the detail of the drug. This is a drug entity. So again, if we put this one, we say this is a patient entity, patient. And here is the prescription. and here is the doctor, and here is the drug. So this is in a practical way, when you design a system, how you convert the requirement into an ER model. So we have, here is the patient information, which is handled by this entity. We have the drug, what is the drug name and supplier, which is handled by the drug entity. We have the doctors who prescribe it, which is by this doctor's entity. And we have the prescription details, which is basically telling me prescription number and the drug and the quantity, which is this one. Now, when you come to this one, you need to build a relationship. So what's the relationship? The relationship is very simple. One patient can have what? Many prescription. But I could have also, okay, one patient has what? 0 prescription. And now I could have the relationship between the prescription and the doctors. I could have one doctors do what? Many what? Many prescriptions. I could have one doctor do what? 0 prescription. And now I need to understand the relationship between what? Between the drug and the prescription. Well, one drug being what? Prescribed many times. I could have one drug never been prescribed in the life by any physicians. So this is how we need to spend time to understand how we put everything together. So we're gonna do a race. Okay, let's do this. We end up this. No, we're gonna disregard it. Now we're gonna come back here. All right. Now let's get it all together. I have in this example, I have a prescription database management system. So I am now going to model a prescription that you go to the doctors, like we see. Usually a prescription has a patient name. A prescription is prescribed by a doctor. A prescription is belong to a drug. So, and then I have the details of the prescription, which is what? This is the prescription. This is the quantity tablet you take in a day and a dosage, which is, we call it prescriptions. Now, I have a patient entity, and that's what we done. A patient entity. Okay, we need to make it smaller so we understand it better. This is a patient entity. This is a doctor, and this is a prescription. And this is the prescription for a drug. So now we have 4 entities. Patient, we have doctors, we have drug. Now this entity include the information about the doctor. Doctor name, doctor ID number, doctor's, specialty. So this is a table in a database, consists all the information about the doctors. This is a table which is to store information about a patient. Patient ID, patient name, address, gender. This is a drug information, the master. Mean every drug we must store information about the drug, like the course ID, course name, credit. We call it master table. Now we have a database consists of 4 entities. This is what? Prescription, mean information about the prescription. Which is the drug? For which patient? What is the quantity? Now we need to do what? Entity. This is 1 entity, 2, 3, 4. Now we need to develop a relationship between them. So this is, we call it entity relationship diagram. In the entity relationship diagram, we need to understand the relationship between the 2 entities, cardinalities. And now let's go through this exercise. The first one is it's called entity relationship between what? Between the patient entity and prescription. Well, one patient, look at that, one patient can have what? Many prescription. Many prescription. That's one. Number 2 is one patient maybe never get any prescription done for him. 0. So the relationship is a noun. Receives. So that's receives. Now we need to know the relationship between the prescription and the doctors. Again, one doctor can prescribe what? Many prescription. Dr. Sam has made many prescription. 1 to many. We can have Dr. Adam, okay, Dr. Adam never prescribe any prescription. So 1 to 0. We could have also the relationship between drug in the pharmacy. You go pharmacy, you see a lot of drug and prescriptions. Well, we could have one drug prescribed to many, has many prescription has made on for that drug. So you go, example, you see one drug that a lot of doctor prescribe it. So we call 1 to many. We could have also one drug never being prescribed. In this case, we call it 1 to 0. We call this cardinality. Now, we need to write the relationship between that. Example, one drug appear, okay, or prescribe, or exist in many prescription. Relationship between doctors and prescription. Right. So we have one doctor write many prescription. One doctor never wrote any prescription. In this case, we have what we call a relational database for a prescription, okay, system. And in this case, this is like the prescription, okay, how it is written by the physician. He writes your name, patient, your name, your address, gender. He writes the doctors who prescribe it. And here is the prescription that consists of one or more than a drug. And these drugs belong to a drug. Now we convert this requirement into an ER model that will help us in implementing the database management system like Access Oracle. So to do that, we need to model that requirement into an ER model. Again, if you recall, this requirement, okay, this is the requirement, prescription requirement. When we came and we break it down, we have patient information, we have doctor's information, which is stored in this entity, we have prescription information, which is stored in this one, and we have the drug information, which is the master, like item master file, which is stored in this one. In this case, we have now 4 entities. This is patient, prescription, drug, and doctors and drug. We need to understand the relationship between them. In this case, one patient has many prescriptions being given to him. We could have one patient who is a healthy patient, has never had any prescription made. So there is no prescription, 0, the circle. We could have one doctor in the hospital, he do want many prescription. And we can have one doctor's, example, interns, which is they are not authorized to prescribe until they get their license, has done 0 prescription. Or we can have a drug, one drug, sold or given or prescribed to many patients. And we can have one drug have never been prescribed to any patient. In this case, we have, okay, done the ER model for what? For a prescription. Now we will apply the same for an ordering system in a minute. We can convert the same for customer making an order for an item, and items come from a supplier. So let's go into this one. Let's say you have a customer, 101, name, first name, middle name, last name, nationality, okay, gender. Let's say here you have a customer address. All right. Now this customer, he comes to, let's say, comes to a business, supermarket, or to a business, and he make an order 101. This is order date. Okay, and here is again the order for an items. Item 1, 2, 3. Okay, this is the unit price. This is the quantity, and this is the total price. So let's look at that. This is item code. This is the name of the item. This is the quantity. This is the unit price, and this is the price for this item. So he come and he take 101, and which is a pen. 10, unit price is 2, is 20. He take 102, okay, let's say 402, another item, and we call it A4 paper. He take 2, it costs 4, so it is an 8. and let's take another item, okay, 301, and let's say is another pen. And this pen, he take 1, and it is 2, and it is 2. In this case, we have now, we need to do an ER diagram. So let's get it all together. Very simple ER diagram for this. We need to do the same as there, which is basically identify the entities. And in this case, the entities here is customer. That's an entity. Another entity is an order entity, which is the order number. Another one is the order item, which is this order details. Another one is the items. These are orders, they come to an items. This is an item. Now, an item could belong to a supplier. So now let's see how many entities. Customer is an entity. So let's get the entity, customer. Another entity is what? Is order. That's an order. Another one, order details. Another one is what? Item. Items come from supplier. Look at that. Nationality. Nationality is another entity. So how many entity I have? 1, 2, 3, 4, 5, 6. 6 entities. So if we convert this into an ER model, we do the following simple things. We say customer entity. We say order. We say item. Order, item. We say here, okay, customer, order, order item, here item, and here is supplier. Okay, now if you remember 1, 2, 3, 4, 5, One, 2, 3, 4, 5. What is missing? 6, which is what? Nationality. In this case, nationality means customer nationality. So here is nationality. So now let's do the relationship. Again, we're going to do the same as this one. We have relationship between customer and order. In this case, customer, place, order. We have a relationship between this entity and this entity. In this case, what? It's a diamond. It's a noun. Order has many items. In this case, an order, okay, items. Order details belong to these items. Items, okay, items. Order items. This is item table. This is item detail. Items supplied by supplier. So now let's look at customer and nationality. What's the relationship? Customer belong to nationality. So now let's do what? The cardinality. Very simple. Well, look at that. One customer, many customer, okay, belong to one nationality. Many customer belong to one nationality. All right? But we also can have what? We can have one nationality. Nobody has made any, not belong. We have a nationality in here, but no customer come from that nationality. Very good. So now we will go to one customer has what? Has what? Many, place many order. One customer place many order. But also we can have one customer has not done any order. Again, we can have one order has what? Many items. But also we can have one order has at least what? One item. We cannot have an order without any item. See how it is done. Now we can have many items, okay, belong to one many item order has one item description. Mean many students enroll in courses belong to one course master details. We could have, in this case, one item has never been exist in any order. We can have now many items belong to what? One supplier. And we can have one supplier has not what? Supply us with one items. Very nice and interesting, okay, example. In this case, we have really modeled the concept of what? Of the requirement for a customer ordering system, which is we have here, think about the invoice that you are getting from any business. You are placing an order. They know your nationality, gender, address. Now here you have what we call the order headers, order details, and the items. Now we need to know how we represent the attributes. Very simple. The attributes, in this case, nationality will be what? Single value with the primary key, nationality ID underscore. Nationality description, single value. Again, customer ID, customer name, which is composite attribute, customer, okay, gender. Now order what? Order number. Order belong to what? To a customer ID. Order underscore number. Customer underscore ID. Order date, item, order, item number, item code, order ID, item description, supplier description.